Hello everyone. In this lecture, we will see how to solve a first order first degree differential equation. Okay. To start with, we have three types of differential equations that we learn to solve. The first one is variable separable differential equations. Second one is the homogeneous differential equations. And third one is the linear differential equations. So let us begin with the variable separable differential equations in this lecture. ನಾನು ಮೊದಲೇ ಹೇಳಿದಾಗೆ ಯಾವುದೇ ಒಂದು ಫಂಕ್ಷನ್ ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ವೆನ್ ಯು ಡಿಫರೆನ್ಶಿಯೇಟ್ ಇಟ್ ಯು ವಿಲ್ ಗೆಟ್ ದ ಡಿಫರೆನ್ಷಿಯಲ್ ಇಕ್ವೇಶನ್. ಸೊ ಟು ಗೆಟ್ ದ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ಅ ಡಿಫರೆನ್ಷಿಯಲ್ ಇಕ್ವೇಶನ್ ಯು ವಿಲ್ ಹ್ಯಾವ್ ಟು ಇಂಟಿಗ್ರೇಟ್ ಇಟ್. Okay, as the name suggests, okay, as the name suggests, the variable separable differential equations, in this type of differential equations the variables can be separated. Okay, how will you separate the variables and how will you solve it? We will see that using the examples, but before that I would like to give you a few steps to solve the variable separable differential equations. So first, what you will solve, in the first step what you will do is you separate out the variables. You separate out the variables. What are the variables that we will have? X and y, along with dx and dy, along with dx and dy. Okay, mind you, this dx and dy must be there in the numerator. These two must be there in the numerator. What do you mean by separate out? In the equation, okay, towards one side if we have x terms we should have only y terms here. If we have y terms here, then we should only have x terms here. Okay, so we are going to separate out the x and y terms like this. Okay, and in the step 2, what we are going to do is we are going to integrate that equation as it is. However you obtain it, you integrate it. Okay, if the variable is x, you integrate it with respect to x. If the variable is y, you integrate it with respect to y. Okay, and then you will obtain the general solution. Okay, and once you obtain the general solution, if they have asked you to get the particular solution, we will see, we will take up a few examples and see how to get the particular solutions. Okay, so we shall first take one problem on this. Okay, so now we have this differential equation, that is dy by dx equal to 1 plus y square divided by 1 plus x square. Look, when they ask solve, they mean to ask the general solution. Okay, so we have to find out the general solution of this particular differential equation. So now, as I had given, separate out the variables in the first step. So what I'll do is I will first write down the given differential equation. What they have given is dy by dx equal to 1 plus y square divided by 1 plus x square. As I said, make sure the dy and dx both are in the numerator. So dy is anyways in the numerator, but dx is in the denominator. I will bring it to the other side, so it would be 1 plus y square by 1 plus x square dx. But here on RHS we have y term also, right? So I will bring this 1 plus y square to the other side. What will I get? I'll get 1 by 1 plus y square into dy equal to 1 by 1 plus x square into dx. So you can see on the LHS we have only y terms and on the RHS we have only x terms. So this is the variable separated differential equation. So variables are separated. Now what I'll do, I will integrate this differential equation on both sides. Okay, so 1 by 1 plus y square dy equal to 1 by 1 plus x square dx. Now I will integrate it on both sides. What do you mean by integrating it on both sides? I will integrate LHS with respect to y and RHS with respect to x. What is the integral of 1 by 1 plus y square? It is tan inverse y. Okay, equal to, what is integral of 1 by 1 plus x square? It is tan inverse x. Okay, both the sides you have integrated, so you will get a constant here, let's say c1. You will get another constant here, let's say c2. If you bring C1 to this side, it will be C2 minus C1. So together I will call it as C. So whenever you integrate a variable separable differential equation, you don't have to write the arbitrary constants on both sides. You can just write one arbitrary constant for one integration, that is C. So therefore, this is the required general solution. Okay, so this is how you will integrate it. Fine. So we'll take up one more example on general solution, and then we will go to the particular solution. So let's go to the next example. So here we have our second example. What is the second example? It says find the general solutions x square x tan y dx equal to x square y tan x dy. Now you can see in the first, there are two terms here. In the first term we have both x and y. In the second term also we have both x and y. So therefore it is an absolute necessity now to separate out the variables first. So what I will do is I will send this term to the other side. What will I get? I'll get sec square x tan y dx is equal to minus sec square y tan x dy. Now you can see on LHS you have dx in the numerator, and on RHS you have dy in the numerator. So ಅದು dx ಮತ್ತೆ dy ಏನು ಡಿಸ್ಟರ್ಬ್ ಮಾಡಬೇಡಿ, ಅಂದ್ರೆ ನ್ಯೂಮರೇಟರ್ ಅಲ್ಲೇ ಇರಲಿ. x ಟರ್ಮ್ಸ್ ನ ಈ ಕಡೆ ತಗೊಂಡ್ಬನ್ನಿ. ಸೊ ಯು ವಿಲ್ ಗೆಟ್ sec square x dx divided by, I'll bring the tan x here, so you'll get tan x dx, I mean tan x equal to minus sec square y divided by, I'll bring the tan y here, tan y dy. Okay, what I will do now is I will integrate it on both sides. So of course, what will you get? See, on both the sides we have sec square x dx by tan x. On the other side we have sec square y dy by tan y. Is it of the form f dash of x by f of x? Yes. What is the derivative of tan x? Sec square x. What is the derivative of tan y? Sec square y. Or else, if I substitute, on LHS, if I substitute tan x as t, I will get sec square x into dx as dt, right? So if I substitute tan x as t, will I get 1 by t sec square x into dx as dt? Yes. So that will be equal to minus. Now what I'll do is on RHS, I will substitute tan y as, let's say, v. Okay, so what will I get? I'll get sec square y dy as dv. So this will give me the integral 1 by tan y is v, sec square y dy is dv. So what will I get? What is the integral of 1 by t? It is log mod t equal to minus, it is log mod v plus c. Okay, but one thing you remember, when you have all the terms in the general solution in terms of log, then it is, I suggest you to write down the constant as log c. I'll tell you why. Why? Because you have two properties, log a plus log b is log ab, and log a minus log b is log a by b. So ಅದೆರಡು ಪ್ರಾಪರ್ಟೀಸ್ ಯೂಸ್ ಮಾಡೋದ್ರಿಂದ ನಿಮ್ದು ಸೊಲ್ಯೂಷನ್ ನಿಮಗೆ ಸಿಂಪ್ಲಿಫೈ ಆಗುತ್ತೆ. ಸೊ ದೇರ್ ಫೋರ್ now what I'll do is log mod t is what? T is tan x equal to minus log mod v is tan y plus log mod c. Okay, so now minus log e kade bandre I will get log mod tan x plus log mod tan y, okay, equal to log mod c. So this will give me log a plus log b is log ab, so I'll get log mod tan x into tan y equal to log mod c. Okay, ಎರಡು ಕಡೆ anti log ತಗೊಂಡ್ರೆ I can comfortably remove log. So I'll get tan x into tan y is equal to c. So this is the required general solution. Okay, that's all. Now this is how you can integrate. Almost all the differential equations are going to be the same. Okay, it is going to be as easy as this. Okay, I shall also take up one next problem. Okay, which will help us to find, I mean, which will be a good example for us to find the particular solution of a differential equation. Okay, so let's go to the next example. Okay, so this is our third problem. Find the particular solution if cos of dy by dx equal to a, where a is a constant, definitely, given that y equal to 1 when x equal to 0. So see, this condition y equal to 1 when x equal to 0 is what we are going to use to find the particular solution. But particular solution find ಮಾಡೋದೇನು ಮೆಥಡ್ ಏನು ಬೇರೆ ಇಲ್ಲ. ಫಸ್ಟಿಗೆ ನಾವು ಜನರಲ್ ಸೊಲ್ಯೂಷನ್ ಫೈಂಡ್ ಮಾಡಲೇಬೇಕು. Okay, so what I'll do is, you can see, except dy by dx ಬೇರೆ ಎಲ್ಲೂ y ಮತ್ತೆ x terms ಇಲ್ಲ, so comfortably I can do it. Okay, I will just consider the given differential equation. Consider, okay, cos of dy by dx equal to a. ನೀವು ನೋಡ್ಬೋದು, ನನಗೆ ಈ dy by dx ನಾನು ಫ್ರೀ ಮಾಡ್ಕೋಬೇಕು, ಬಿಕಾಸ್ ನಂಗೆ dx ಮತ್ತೆ dy ಎರಡು ನ್ಯೂಮರೇಟರ್ ಅಲ್ಲಿ ಬೇಕು. ಸೊ ಕಾಸ್ ಅದನ್ನ ಹಿಡಿದಿಟ್ಕೊಂಡಿದೆ. ನಾನು ಕಾಸ್ ಅನ್ನ ಆ ಕಡೆ ಕಳಿಸಿದ್ರೆ ವಾಟ್ ವಿಲ್ ಐ ಗೆಟ್? ಇದು ಆ ಕಡೆ ಕಳಿಸೋದಲ್ಲ, ಬಟ್ ಓಕೆ ಫೈನ್. ಸೊ dy by dx equal to, I will get cos inverse a. Okay, a is a constant, so therefore cos inverse a is also a constant. Don't get confused. Cos inverse a is a constant. There is no variable in it. Okay, it is very harmless there. So this implies dy is equal to cos inverse a dx. Okay, now if I integrate this equation on both sides, I'll get dy equal to, cos inverse a is anyways a constant, I'll keep it outside, I'll get integral of dx. Integral of dy is nothing but integral of 1 dy. Integral of 1 with respect to y is y, equal to, just a minute, y equal to, I will keep cos inverse a as it is. Integral of 1 with respect to x is x. Okay, plus I will write the integration constant c. Okay, I will call this as equation 1. Equation 1 is the required general solution. It is not required, I mean, it is the general solution. Okay, once we have the general solution, we will use this condition to find out the integration constant. See, a is the constant that they have given. Okay, if they give sufficient data, then we can find out the value of a. Otherwise we will have to find out the value of c alone. Okay, so ನಾವು ಫೈಂಡ್ ಮಾಡಿರೋ ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂನ ನಾವು ಫೈಂಡ್ ಮಾಡಿ ಅವ್ರಿಗೆ ಕೊಡ್ಬೇಕಷ್ಟೇ, ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ನಾವೇನು ಮಾಡೋ ಹಾಗಿಲ್ಲ. y equal to 1 when x equal to 0 ನ equation 1 ಅಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡು. Okay, so we have y equal to 1 when x equal to 0. So therefore equation 1 implies, equation 1 ಅಲ್ಲಿ y ಇದ್ದಲ್ಲಿ 1 ಹಾಕಿದ್ರೆ x ಇದ್ದಲ್ಲಿ 0 ಹಾಕಿದ್ರೆ I'll get 0 plus c. So this will give me c equal to 1. Okay, so therefore ಇವಾಗ c value substitute ಮಾಡಿದ್ರೆ I'll get the particular solution ಅಷ್ಟೇ, ಮತ್ತೇನಿಲ್ಲ. ಆರ್ಬಿಟ್ರರಿ ಕಾನ್ಸ್ಟೆಂಟ್ ನಮ್ಗೆ ಏನು ಬಂದಿರುತ್ತೆ ಅದರ ವ್ಯಾಲ್ಯೂ ಫೈಂಡ್ ಮಾಡಿ ಅವ್ರಿಗೆ ಕೊಡ್ಬೇಕು ಅಷ್ಟೇ. So therefore the particular solution is, so what is the particular solution? We have the particular solution is given by what? Y equal to x cos inverse a. The general solution will remain the same. Okay, x cos inverse a plus the c will be equal to 1. So therefore this is what we have. So this is going to be the particular solution. That's all. Okay, general solution ಹೇಗೆ ಫೈಂಡ್ ಮಾಡ್ತೀವಿ ಹಾಗೆ ಫೈಂಡ್ ಮಾಡಬೇಕು, ಬಟ್ ದೆನ್ we will have to find out the value of the arbitrary constant and then we will have to substitute it in the general solution. Okay, so we have a few application based problems in this. Okay, that we will discuss during the checklist discussion. Okay, application based problems andre, if I go to NCERT, you can see there are these problems. At any point x comma y of a curve, the slope of a tangent and all those things. Okay, that we will discuss during the checklist discussion. Okay, so I think we can discuss this problem here. The general solution of the differential equation dy by dx equal to e raised to x plus y. Okay, you can see dy by dx equal to e raised to x plus y can be written as e raised to x into e raised to y. Why? A raised to m plus n is a raised to m into a raised to n. So e raised to y ikkada bandre e raised to minus y dy equal to e raised to x dx. I think you can integrate and find out the general e raised to minus y do minus e raised to minus y. If you integrate it on both sides, equal to e raised to x plus c. So I think plus c plus c1 anta karadre plus c1 ಈ ಕಡೆಗೆ ಬಂದ್ರೆ I will call it as c. So e raised to x plus e raised to minus y equal to c. E raised to x plus e raised to minus y equal to, so it's option A. Okay, so other than this, this bacteria culture problem and all are good 5-mark question that we will discuss this during the checklist discussion. Okay, thank you.